At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it.
You lose! Good day, sir!
Hi, welcome to CheMistakes. Here I go through actual students' incorrect answers in chemistry class, try and work through them in a way that can help you understand the chemistry a little better. Here we're going over naming and formula writing, so some basic chemistry stuff, and lots of things crop up in this that kind of linger for a long time, so it's important to straighten out and make sure you have a good understanding. So here we have name the following. We have MgBr2, CaCO3, and SNO2. And so all of these cases are examples of students who have a certain thing that they're not quite certain of, and let's go through and look at each one. In the first one we have MgBr2, and they've named it magnesium dibromide. So the actual name on this would just be magnesium bromide, but let's go through why that naming is different, and why this is incorrect, and why that particular student is confused. Okay. So the key in naming is in order to get from the name to the formula, you need sufficient information, but you also, generally speaking, want to have the minimal amount of information needed. There's a laziness aspect there. We don't want to communicate extra. So between these two things, you should be able to get from one to the other with enough information. Now, when you have something that's ionic, something that's composed of a cation and an anion, or some people would also say this as being composed of a metal and a nonmetal. In that particular case, you don't need to provide a lot of information. If you just provide what the two ions are, that's sufficient for everyone else to be able to figure out what the formula is. So when I say magnesium bromide, and I'm talking to someone who has a basic understanding of chemistry, what they then know is they know they can look up what the charges of these things are based on their position on the periodic table. So they can look up and say, oh, okay, magnesium is in this column, it has a 2+ charge when it's in its ionic form, when it's in ion form. And bromide is in the halogen column, that's going to have a -1 charge. So the formula for that would be MgBr2, so that I balance the total charge on that. And therefore, that's all the information I need. The dye is unnecessary. I don't need you to tell me that there are going to be 2 bromines. I already know that from just knowing that it's magnesium and bromine. So for ionic compounds, using prefixes is not appropriate. Now, there are cases outside of chemistry class where people do that in an inappropriate sense because of historical reasons or just because they're not as lazy perhaps as the rest of us are. But in a technical, correct naming system form, that's the way that you would want to go. Now, for the second one, here we have CaCO3 and the name given is calcium carbon trioxide. So this is a common problem, but basically the issue here is that the student does not recognize polyatomic ions. So anytime you're seeing more than 2 elements, you want to be suspicious that you're looking at a polyatomic ion. And depending on what your class does with that, either you have a sheet with you or you've memorized them or whatever, but you need to just know what this is. So you need to recognize the CO3 there as carbonate. So the correct name of this would be calcium carbonate. But let's go a little further on that. One of the issues that a lot of students have is they can recognize the polyatomic ions when written out as polyatomic ions in isolation. The student can recognize this as being carbonate, but when I write the formula CaCO3, all of a sudden that obscures part of this and they don't recognize it. So it's important to note that when we're writing these formulas that the ions present within them do still have their charges. We don't write them because, again, we go back to the laziness factor. We don't have time to do it and it's very messy. But this is a 2+ charged ion with a 2- charged polyatomic ion. And so the 2- is kind of embedded within that formula. And so therefore it's important to be able to recognize that in both forms. And a lot of times what we'll do is we'll start with, know this is carbonate, but then we never transfer that to know this is carbonate. A lot of people miss that. Okay, but on the other side of things, it is also just really important to know all of your polyatomic ions. Without a really quick knowledge of what these are, you're not going to be able to recognize this fast enough to be able to name it properly. It's going to become frustrating. So you also want to be highly proficient at being able to write those out in a memorization aspect. So if you're not being forced to do that, force yourself to memorize the common polyatomic ions. All right, now last one here is tin-2 oxides. The student response, it's SNO2. So tin can form 2+ and 4+ charges as multiple charges available to it. And so it's important to specify what the charge is in parentheses. The problem with this one is that SNO2 is not tin-2. So this is a very common problem that causes a lot of mistakes. The oxygen here has a 2- charge. So when I have two 2- charges and then one tin to balance that out, that means that the charge of the tin must be 4+. And so anytime you have a compound with multiple charges and something like oxygen or sulfur, you need to be very careful about figuring out the actual charges. A lot of students will incorrectly learn that the subscript here is what you write in the parentheses, but the parentheses describe the charge of the metal ion. Now the reason for that is because a lot of times we look at compounds like this, where the charge of the anion here is -1. And so in that case, the subscript is the charge of this. So this is tin 2 chloride, this is tin 4 chloride. So it's easy for a student then to go, oh, well the 2 must mean this, and the 4 must mean this, but it doesn't. It just happens to be the same thing because the charge of this is 4+, and the charge of this is 2+. Flash forward to oxygen, all of a sudden that's a problem because this is not a -1 charged ion, and so now we run into issues where we mess that up. This is tin 4 oxide, would be the correct name of this. And so that's what you kind of want to watch for there. Now let's go with the whole thing in reverse now. So now we're going to go ahead and have some names given to the student, and we're going to go ahead and look at their answers for that. First one here is calcium chlorate, and we get CaClO6. So calcium is a 2+ charged ion. We can figure that out from the periodic table. Chlorate is a -1. So it appears what the student has done here is they've taken this and said, okay, we need 2 of these, but they've only doubled the oxygen. And that stems from a misunderstanding of what is a polyatomic ion. So a chlorate ion is a chlorine surrounded by oxygens in a way where they're all connected to one another. So there's bonding between these 4 particles that kind of holds them all together. And then the 4 particles themselves carry with them 1 additional electron. So if we're to count up all the electrons of all 3 oxygens and the chlorine, and compare it to how many the chlorate ion has, it has 1 additional one. So chlorine 17 and 24. So this should have 41 electrons if my math is going well. This has 42. And so it's got a -1 charge to the whole thing. Okay. So when we want 2 of these chlorates, you can't just take the oxygens. You have to take the whole thing as one thing. And so what we do for that often is we say, okay, we're going to put the chlorate in parentheses, and then we're going to do 2 of the chlorates. So that would be the way you would write that formula. That gives you your balanced charge. It's 2 -1 charges for every 1 + 2 charge. Okay. Sodium oxide, NaO. Problem here is that they're overlapping with the molecular compounds, where in molecular compounds you use prefixes. So you would say, you know, phosphorus dioxide or carbon dioxide or something like that. And so since there's no prefix here, the student is just writing down the 2 elements. They need to balance the charges. So again, we need to go to the periodic table and look up what these are if you haven't memorized them yet. Sodium is in the first column, forms +1 ions, oxygen 2- ions. So therefore, a formula for this should be Na2O. Okay. And on the last one here, we are looking at copper 2 oxide. The formula given was CuO2. If we look at the ions, we'll see that that doesn't make sense. Copper 2, the 2 here means we have a 2+ charge in the copper. Oxygen, of course, has a -2 charge. And so therefore, when we put this together, our actual formula should be CuO. I'll point out in all of these are all reasonable responses. They're all incorrect, but there's a line of logic there. And it's important that when you're learning this, you go through and make these mistakes and then correct them. A lot of people try and just look at right answers for this, and then they don't really ever get a point where they get challenged on something. So it's important to look at incorrect answers too, and make sure that you're making those mistakes with whatever practice you have available to you.
Okay, a simple wrong would have done just fine, but